Hi, I'm Troy Bach. I'm doing my universal design video. I'm team one. Our team consists of four members: Jaden Thompson, Troy Bach, Nathan Meyer, and Benjamin Martin. Our toy name is called the S Maze. Um, Here are a few rough drafts and dimension measurements of the S maze. On the left, over here, you could see the final project of the S maze in on shape and its connective mounting points. Here you could see a few sketches of the model in on shape, and to the right, you could see rough measurements. As we could see, the total length of the S maze is 2.71 inches vertically, and horizontally it is 3.959 inches horizontally. And for the upper and lower components, we could see that it's 0.67 inches and 2.04 inches. As you can see, the maze has these little mounting points that was originally meant for the acrylic. On the bottom here, we could see the acrylic and the little holes and mounting points associated with the acrylic. And what is underneath the acrylic in terms of mazes, right here, you could see a hole in which it holds the a quarter of an inch diameter balls that were provided to us, and we did not have to print, but we had did the measurements to accommodate um, the balls, and everything fit nicely. There was an issue with these mounting points, but I will get to that. Here's some pictures of the final results. As we could see, the maze and the ball all work fine, implementedly very good. They sit in the holes. There was an issue, however, with applying uh, the adhesive and super glue to our acrylic, in which it would like smear when trying to apply pressure. And as you could see, there's little white smears of glue, and this was annoying. And it smeared because the mounting points sadly were damaged and the acrylic moved freely, and I had to um fix the placing. But overall, it came out nicely. Nice print, good spin. It's durable too, even with the acrylic. I had dropped the final project quite a few times off the table. Still keeps spinning, banging against walls. Works completely fine. The maze works as wanted. We could see in the original prototype idea, it more resembled the Bay blades and it was more like angular and rudimentary, and we had more of a spherical turning point. Discussions and trade-off between the toy features. Um, the three major things that we discussed were the um the trade-offs, in terms of trade-offs at least, was accommodating, making the spinner like light enough to accommodate the maze without disrupting the function of its, like making the maze large enough to be fully functional and entertaining, while also making our shape like able to spin well. There's two problems with this, was the size of the maze itself and the size of the ball. Luckily, we have implemented a system where the maze is large enough where it doesn't disrupt the functionality or spin of the ball at all. And the ball, it's only a quarter of an inch diameter, so it won't significantly in any way disrupt the spinning motion of our toy. Um, Incorporated elements of universal design. cost. The simple and intuitive design makes it so users of all ages and languages can comprehend how to use the toy with ease. In terms of sustainability in the engineering field, our design helps engineers sustainability by addressing the triple bottom line. This toy helps people by giving them a toy that can help engage their creativity and motor functions. The toy helps the planet because it's made using renewable resources to form the plastic in the toy. The design helps the prosperity by potentially being used by small-time restaurants and or stores to create contributions to local economies. In terms of intellectual property in our projects, one of the major difficulties we faced was trying to make our projects not resemble the Beyblade spinning tops, which were a patent by Takahara Tomy. And we had originally tried to implement this, as you could see in our original prototypes ideas. They look very similar to the Beyblade. However, this was not a good idea because of copyright laws, and we opted out for more rounded and smooth and spherical design for our spinner instead of the hexagonal shape of the Beyblade, which resembles that in our prototype. Recommend the recommended future action. If we were to recreate this prototype here, we would obviously um, apply the adhesive on the acrylic in a different way. In the future, we would implement clamps to prevent any of the adhesive smearing around on the acrylic top and disrupting the look of the acrylic. In terms of the mounting points, in our original design, our team had implemented mounting points, as stated earlier, for the acrylic top to fit onto. However, these mounting points had fallen off because they were too weak. If we were to remake the acrylic top mounting point, we would make it so the points are shorter and wider, which this would potentially prevent them from being damaged and make them much stronger. Finally, for our future actions, if we were to like recreate this, the center of weight, we would consider lowering it to make our spin more stable. As you can see here, the majority of the weight is on the top of our project. Um, this could interferes with stability sometimes, not all the times, but if it were lower, it'd be definitely more stable and uh, the fluidity of the spinning would be better. Now, finally, for the video.